We have a vector valued function r vector given by cosine of nt I cap plus sine nt j cap. Here n is a constant and t is a parameter that varies. We need to show that the cross product between the vector r and its first derivative with respect to t is n times k cap. So let's begin. Let's note down the vector r. So that's r vector is cosine of nt I cap plus sine nt j cap. Let's determine its derivative with respect to the parameter t. Here we will consider I cap, since I cap and j cap are constant vectors, so the derivative with respect to t will be equals to 0. So that means we have to find only the derivative of the components of I cap and j cap with respect to t. So the derivative of the cosine function, that's negative sine t, and we also have the factor n multiplied to it, which results as a consequence of the chain rule. So this is I cap plus n times cosine of nt, where cosine is the derivative of our sine function. So this is j cap. Next, what we need to do is find out the cross product between r and its derivative with respect to t. So here we will use the determinant, a 3 by 3 determinant. I cap, j cap, k cap will be the components, or there will be the entries in the first row, and the second row will have to consider the entries of vector r. So that's cosine of nt. For j cap, that will be sine of nt, and we do not have any z component, so that will be 0. Then in the third row we have components of the first derivative of r with respect to t. That means the components of this particular vector. So in the first column, the entry will be negative n sine nt. The second entry will be n times cosine of nt. So there is no z component, so that will be simply 0. Now let's expand this particular determinant about the first row. So we will have I cap multiplied to the 2 by 2 determinant sine nt 0 and cosine t 0. So that's 0. Minus j cap times, we'll have to take the 2 by 2 determinant with the entries cosine of nt 0, negative n sine nt and 0. So this is also going to be 0. Plus k cap times, we'll have to consider the entry cosine of nt, sine nt, and in the second row we have negative n sine nt and n cosine nt. So this will be, so we have cosine of nt times n cosine of nt, so that will be n times cosine squared nt. Minus, we have sine of nt times negative n sine nt, so that will be negative n, so that becomes positive sine squared nt. Now this will be k cap time, so we'll take n as the common factor from both the two terms. That will leaves us with cosine squared t plus cosine squared nt plus sine squared nt. Now this being an identity with the value equals to 1. Now that means we have n k cap. Now that is what we were asked to prove, that the cross product between the vector r and its first derivative with respect to t gives us n times k